Hi everyone, welcome back to my YouTube classes. It's Divya here with class 11 physics. Now in the last video we have seen about relative motion. Now we are coming to another important topic, that is your projectile motion. Now this projectile motion can also, somewhere if you see for other reference book, you can see this word also, that is ballistic missile. So both are same, it is going to be projectile motion. Now, what is this projectile motion? See, whenever you throw an object upward, till now you have seen the vertical cases, isn't it? Just vertically upward. So, you have solved numericals with that also. Now, here we are going to consider a case where an object is thrown upward but not vertically. Okay, you can throw it not vertically, you can throw it like this, just forward. It is not in the upward direction, isn't it? So in that case, if an object is thrown upward without in the vertical position, then on that object the acceleration due to gravity is going to act. And such motion which is thrown upward other than vertical motion acted upon by the acceleration due to gravity, you call it as a projectile motion. Okay. Now when you talk about this projectile motion, the path followed by an object is called as trajectory. Okay. So the path followed by a projectile, you call it by the word trajectory. Okay. Now this trajectory of a projectile motion will always be a parabola. Okay, the path followed by a projectile motion, or the trajectory in case of a projectile motion will always be a parabola. So we will prove this, that is the path followed by, or the trajectory of a projectile is a parabola. We are going to prove it. Okay. Now before going into the proof, we are going to consider this parabolic figure. Okay, I will redraw this. Now I told you are going to redraw the figure, you are going to make it in a Cartesian coordinate. Okay, so this is your x-axis, y-axis, and I told you the path followed by a projectile will be your parabola. Okay, so path followed by a projectile is going to be a parabola. I have drawn a parabola here. Now if it is a parabolic or in a curved surface, in each and every point the direction is going to change, isn't it? Each and every point the direction keeps on changing. Now, at this point you are going to consider a point here, and that is going to be your initial velocity u, and some other points you can have your final velocity v. Okay, so we have already seen the vector resolution. You can resolve it into u, x and u, y. So combining these two, both the effect will be same as that of your initial one, u. Similarly, v also you can resolve it as v, x and v, y. Isn't it? Now as the projectile goes, since it is a parabolic, it will be having a peak point. Isn't it? Now the main thing you have to remember here is, for a projectile motion, at the peakest point you will not have your vertical component or your y component. You are going to have only your x component. It will be ux or uy, whatever it is, you are going to have only your x component. Here ux or vx or whatever it is, y component is going to be 0 at the peakest point. Okay, got it? So this is all about the introductory part. Now let us come to the derivative part, where first we are going to prove the path followed by a projectile, or the trajectory of a projectile is going to be parabola. Now let us prove it now. Now before proving it, I told you you have resolved it. Now one thing, when you resolve it, ux, how can you write it? Resolving vectors I have already told you. Ux, if you consider it to be a right angle, and if you are going to take this one as theta, how will you write ux? Ux will be equal to u cos theta, and uy will be equal to u sin theta. Isn't it? Now, one thing I told you, since it is in a parabolic or in this shape, the vertical component will be 0 at the peak point, which means that the vertical component keeps on changing at each and every point. But what about the horizontal component? Horizontal component will remain the same since under action of gravitational acceleration due to gravity. Now, after resolving, you will get the two components. Ux equation will be u cos theta and uy it will be u sin theta. Isn't it? Now what we are going to do is that we are going to write equation for displacement. We want to find the displacement. Then only we will get the path, isn't it? Now displacement along horizontal and displacement equation along vertical axis. Okay. Now displacement along horizontal axis, you can take displacement as is equal to x. Now for x, if you are going to write the equation, how will you write it? How can you write it? That is, you are having the equation velocity is equal to displacement upon time, or displacement will be equal to velocity into time. So this is a basic equation you are learning, isn't it? So here, instead of displacement, you are having horizontal displacement x. Now horizontal displacement x will be equal to velocity into time. Here the horizontal velocity you have taken it as ux into time t. Or ux you are having u cos theta into t time t. Is that right? Now from here equation number 1, can you write what is t? T if you write it will be x upon u cos theta. Isn't it? Now similarly if you are going to write it for the vertical component, vertical displacement you will take it as y. So vertical displacement, which equation you are going to use? Equation of motion S is equal to ut minus half g t square y. This is the equation for the case of acceleration due to gravity. I told you for projectile motion, what is the force taking place there? Gravitational force or acceleration due to gravity. So you will take the equation for under acceleration due to gravity. Now according to this equation, instead of S, vertical displacement y I have written, then u will be vertical u y, that is u y into t minus half g t square. Now instead of u y you are having u sin theta. So y will be equal to u sin theta into t minus half g t square. Any doubt? Now see, you can replace this t with this equation. Isn't it? You have already got an equation for t there. So you are going to replace the t with the equation you have got it there, and accordingly how you can write? Y will be equal to u sin theta into, instead of t it will be x upon u cos theta. Isn't it? Minus half g into, again instead of t square you will write x upon u cos theta the whole square. Isn't it? Any doubt? Now when you see this u and this u will get cancelled. Isn't it? This u and that u will get cancelled, and what is remaining? What is remaining? Y is equal to sin theta into x by cos theta. Then what is remaining there? Minus half g into x by u cos theta the whole square. So this is what is remaining, isn't it? Now what is sin theta by cos theta? It is going to be tan theta, isn't it? So you can write y is equal to x tan theta minus half into g x square upon u square cos square theta. Okay. Now when you see this equation, when you analyze this equation is going to be quadratic in x and linear in y. Isn't it? It's going to be, when you analyze this equation, you will find that this equation is going to be quadratic in x and linear in y. So such a satisfying equation is that of a parabola, and that is why we told that the trajectory or the path followed by a projectile is a parabolic. Got it? So this is can be asked as a derivation part. Go through this. See that you have any doubt. If you have any part with the doubt with this part, put it in the comment box. I will clear it. Okay. Now this is how we are going to prove that projectile motion or trajectory of a projectile motion is going to be parabolic. This is one essay part. So with this I am going to wind up with today's portion. Till we see in the next class. Take care, stay safe, and bye bye.